For more than 300 years, one mathematical problem has refused to surrender. Take two objects in space, and their motion becomes beautifully predictable. The Earth around the Sun, the Moon around the Earth. Elegant, stable, understandable. But add just one more object, and certainty begins to disappear. Tiny changes become enormous consequences. Prediction becomes almost impossible. Mathematicians call it the three-body problem. Some believe it proves the universe is fundamentally chaotic, random, unpredictable. You will discover why one of mathematics' greatest mysteries may actually reveal extraordinary order. You will see what modern AI simulations are teaching astronomers. You will understand why our own solar system is astonishingly stable. And you will uncover a question that reaches beyond mathematics itself. Because perhaps the greatest mystery is not why chaos exists. Perhaps the greatest mystery is why anything remains ordered at all. Part 1. The problem that defeated Newton. In 1687, Isaac Newton changed the world. His law of universal gravitation explained something humanity had wondered about for thousands of years. Why apples fall, why planets orbit, why moons circle worlds. His equations worked beautifully for two bodies, one object pulling another. The mathematics becomes elegant, precise, predictable. Astronomers can calculate eclipses centuries in advance. Space agencies can launch probes across billions of kilometers with astonishing accuracy. But then mathematicians asked a simple question. What happens if we add one more object? Not two bodies, three. Suddenly, everything changes. The equations still exist. Gravity still behaves exactly as expected. Yet the interactions become so complex that no general closed-form solution exists. The system becomes extraordinarily sensitive. Move one planet by only a fraction, and millions of years later, its position may be completely different. This became known as the three-body problem, one of the greatest unsolved challenges in classical mathematics. Part 2. The man who discovered chaos. In the late 19th century, French mathematician Henri Poincaré entered a competition sponsored by King Oscar II of Sweden. The challenge? Solve the three-body problem. Instead, Poincaré discovered something even more remarkable: deterministic chaos. The system followed perfect laws. Nothing random occurred. Yet tiny differences in initial conditions produced dramatically different futures. The mathematics remained lawful. Prediction became extraordinarily difficult. Decades later, meteorologist Edward Lorenz would rediscover the same principle while studying weather systems. A tiny rounding error inside a computer simulation produced an entirely different forecast. This became famous as the butterfly effect. A butterfly moves its wings. Months later, a hurricane develops differently. Not because reality is random, but because complexity amplifies tiny changes. Chaos is not the absence of order. Chaos is order so intricate that human prediction struggles to follow it. And this distinction changes everything. Part 3. AI enters the cosmos. Now, something remarkable is happening. Artificial intelligence is becoming one of astronomy's most powerful tools. Modern machine learning systems now simulate millions of gravitational interactions, entire planetary systems, binary stars, triple star systems, galactic collisions, configurations that would take traditional computers enormous amounts of time to analyze. And the results are fascinating. Most randomly generated systems fail. Planets collide, stars eject companions, orbits collapse, entire systems become unstable. Only a relatively small number remain stable across immense periods of time. Think about that. AI is discovering that long-term stability is surprisingly rare, not impossible, but remarkably delicate. a tiny adjustment can transform harmony into instability, and suddenly the question changes. If instability is mathematically common, why does our own solar system exhibit such extraordinary long-term order? Part 4. The solar system should amaze us. Every second, billions of gravitational interactions occur throughout our solar system. The Sun pulls Earth. Earth pulls the Moon. Jupiter influences Mars. Saturn influences Jupiter. Asteroids influence one another. Even distant stars exert incredibly small gravitational effects. And yet, our planetary system has remained astonishingly stable for billions of years. Well, the dates are suspicious, but for now we will leave that there. Earth's orbit remains within a remarkably narrow habitable range. The Moon stabilizes Earth's axial tilt. Jupiter acts as a gravitational shield for many incoming objects. Orbital resonances maintain extraordinary balance. Astronomers continue studying why this configuration has persisted for so long. None of this proves design, but it does reveal something profound. Stable order is not trivial, it is extraordinary. And perhaps we have become so familiar with order that we no longer recognize how remarkable it actually is. Part 5. The Fine-Tuning Paradox. Now I will talk about what makes the mystery becomes even deeper. Physicists often speak about fine-tuning, not as proof, but as an observation. The universe appears remarkably balanced. The strength of gravity, the electromagnetic force, the expansion rate of the universe, the ratio of matter to energy. Tiny changes to many of these values would produce dramatically different realities. Stars could never form, galaxies would never stabilize, chemistry would collapse, complex life would never emerge. Physicist Paul Davies once remarked that the impression of design is overwhelming. Roger Penrose estimated the probability of our universe beginning in such a low entropy state as astonishingly small. Whether one agrees with their philosophical conclusions or not, the observation remains. Reality appears extraordinarily ordered, which creates a fascinating paradox. The three-body problem teaches us that complexity naturally amplifies instability. Yet the universe repeatedly produces stability, not just locally, but across billions of light years. The question is no longer simply mathematical. It becomes philosophical. Why does reality permit order at all? Part 6. Information always has a source. Now another discipline enters the investigation: information theory. Claude Shannon transformed communication science by demonstrating something profound. Information is measurable, structured, transferable. DNA functions as information. Computer code functions as information. Language functions as information. The universe itself appears governed by mathematical information. Equations describe galaxies. Constants govern atoms. Geometry shapes crystals. Patterns appear everywhere. Even artificial intelligence depends entirely upon structured information. AI does not generate itself. It requires data, architecture, rules, relationships, source. And suddenly, an unexpected parallel appears. The deeper science investigates reality, the more reality behaves like information instead of chaos, which raises a remarkable possibility. Perhaps existence is not merely matter. Perhaps existence is structured meaning. Part 7. The psychology of order. Now consider the human mind. Neuroscientists have discovered that our brains are extraordinary pattern recognition systems. We instinctively search for structure, faces in clouds, rhythms in music, constellations in stars, mathematics in nature. Some dismiss this as coincidence, but something curious happens. The more science advances, the more discoverable order appears. The Fibonacci sequence emerges throughout biology. Fractal geometry appears in coastlines. Snowflakes organize themselves. Planetary motion follows mathematical relationships. DNA stores digital information. Quantum mechanics follows astonishing precision. The universe behaves as though it is intelligible. Albert Einstein once expressed his amazement. The most incomprehensible thing about the universe is that it is comprehensible. Think about that. Why should a random universe produce minds capable of understanding it? Why should mathematics written on paper describe galaxies billions of light years away? Why should consciousness be able to discover laws that existed long before humanity? The mystery continues to grow. Part 8. The Insight. Source, expression, and continuity. Across every level of reality, a pattern quietly repeats. Source, expression, continuity. A star, its light, its continuing radiation, DNA. Its expression, its inheritance. An idea, its communication, its preservation. Artificial intelligence, training data, model expression, continuous learning. Even stable planetary systems follow the same architecture. A source, relationships, continuous interaction. Remove the source, expression disappears. Remove continuity, structure collapses. Perhaps this is why Scripture repeatedly presents reality relationally rather than mechanically. Father, Son, Spirit. Not isolated existence, but continuous sustaining existence. Not static being, but living relationship. And suddenly order begins looking less like an accident and more like the natural consequence of perfect alignment. Part 9. What science actually says. One misconception deserves correction. Science does not prove God. Science does not disprove God. Science investigates observable reality. It measures, tests, predicts, repeats. The philosophical conclusions come afterward. This is important because honest investigation is not the enemy of faith. It is one of its greatest allies. The three-body problem does not say there is no design. It demonstrates extraordinary complexity. AI simulations do not prove randomness. They reveal astonishing sensitivity. Astronomy does not eliminate wonder. It multiplies it. Every discovery expands the question, not merely how, but why. Why mathematics? Why information? Why beauty? Why consciousness? Why laws that remain stable across billions of years? And perhaps the greatest scientific discovery is not certainty, but humility. The deeper we look, the larger the mystery becomes. Perhaps the three-body problem is teaching something far greater than orbital mechanics. Perhaps it is reminding us how extraordinary order truly is. Every stable orbit, every galaxy, every atom, every equation, every living cell exists within relationships so delicately balanced that small changes could transform everything. The Apostle Paul wrote nearly 2,000 years ago, "In him all things hold together." For centuries that was read only theologically. Today it carries a remarkable philosophical resonance. Reality appears astonishingly coherent, not because chaos does not exist, but because order continuously overcomes it. Maybe that is why stars continue burning, why galaxies continue rotating, why mathematics continues describing reality, why consciousness continues asking questions. And perhaps the greatest miracle is not that chaos exists, The greatest miracle is that anything remains beautifully ordered long enough for us to discover it. The three-body problem remains unsolved. Mathematicians continue exploring it. AI continues modeling it. Astronomers continue studying it. Yet perhaps its greatest lesson is already visible. The universe is not remarkable because complexity exists. It is remarkable because complexity so often becomes harmony. And every stable orbit silently asks a question that no telescope can answer. Why does reality continue holding together when mathematics tells us just how easily it could fall apart?